space-age-miracle-tools.js. Everybody calls me NJ because it's easier than trying to pronounce my actual name, so NJ it is. And I'm not websafe on Twitter. And I work at Adobe on a project called Brackets, which I helped start. Brackets is a code editor for web developers, and it's built almost entirely in HTML, CSS, and JavaScript, and a little native stuff around it so that it can access the local file system. And it's completely open source, MIT license, and stuff like that. Has anybody here actually tried Brackets out? Like, oh, good. Has anybody ever actually tried to hack on Brackets or write an extension for it? All right, you don't count, Brian. I mean, no, you count a lot. I just mean, OK. So well, maybe we can give it a couple people. So I called this talk space-age-miracle-tools.js, which is kind of a terrible name, because how could you possibly live up to a name like that? But what I'm going to show is some sort of early experiments, some ideas we have for future developer tooling, and we kind of want your feedback on whether these things make sense, whether there's something that you think we or other people should pursue. And then on top of getting feedback on these ideas, we also want to hopefully inspire other people, you guys, to think about what kinds of developer tools would you like to see for the next 10 years for the challenges that we're going to be facing in the future, or even are facing now, that maybe aren't adequately addressed by the kinds of tooling that we have today. So this is going to be a sequence of demos, and I didn't actually do most of them myself, so I'm going to introduce who actually worked on them. So the first one's called Theseus, and it's done by Tom Lieber, who I think he's just finishing a PhD at MIT, and Joel Brandt, who works at Adobe in their research group. And the problem they're trying to solve is that debugging asynchronous code, I mean, we're web developers, right? We have to deal with this all the time. And it's super fun, right? Right? Yeah. So basically, you see something's wrong in your web app, and then you have to kind of guess where the problem is by reading all your code on the client, maybe on the server, right? It could be either place. And then because the problem might be in asynchronous code, you can't just step through all your code, right? You have to think about every single place your code might go, and then add breakpoints or log statements or whatever, and just sort of scatter them all over the place. And then reload, try to figure out what's going on. And then if you haven't fixed it yet, then you kind of have to rinse and repeat. So it's kind of a pain in the ass, right? So the idea of Theseus is to make it easier to debug this stuff by basically capturing information as we go along. So to see this, let me go ahead and start at Brackets. And if you haven't seen Brackets before, as you can tell, it pretty much looks like a text editor on the surface, right? It's just got the standard stuff you'd expect, like code coloring, and it's got a little file tree and stuff like that. I'll show some of the more specific features that we already have in Brackets later on. But right now, and all this stuff is built in HTML, like I said, and JavaScript. But let me go ahead and show you how this Theseus stuff works. So let me start by starting the server for it. So this is my server app, but what I'm going to do is instead of starting it in Node, I'm going to start it in Node Theseus, which is going to instrument it in certain ways that we'll talk about later. OK, so this is running my Node app now. And then from Brackets, I'm going to enable Theseus. And I'm going to go to the source code for that project. Whoops. And I'm going to go into this live development mode. OK, so now I'm running this application. And this is just like a simple demo app. It's a reservation application, right? And so the idea is you're supposed to be able to select an activity you want to do, and then select which date you want to do it on. But as you can see, there's no actual dates in the dropdown, right? So there's a bug somewhere. So where's the bug? Well, it could be in this event handler for this dropdown, right? It could be that we're not kicking off the AJAX request properly. It could be that on the server side, it's not accessing the database properly, or it's not returning the response properly, or whatever. So it could be in a bunch of different places. So because we were running this all in the context of Theseus, we can actually go back and look at our source code. And now I'm going to switch to my client-side JavaScript. And you can see that as I've been doing stuff, it's actually been capturing information on which functions got called, right? And this is live, so if I go and I pick another activity, let's say, like running or something, you can see that it updates what got called. So that's kind of useful. And I can also click on these things to get more information. So for example, we can see that our change handler got called 2 times, which is what we would expect because we picked 2 different things from the background. Yeah. Oh, I'm sorry. Is that better? Yeah. Better? Is that right? OK. So you can see that we've got a change. Oh, I can make it even bigger. So we've got a change handler here, right? And that got called, which is what we would expect. And so I can click on that. And I'm sorry, I can't increase the font size of this right now. But basically, it's showing me information about each of those calls. And I can also look at some other stuff. Like there's this setUpDates function, which got called also twice. And then there's an AJAX post. And then there was a callback function that got returned, or that got called when the data was returned, right? So I can click on all those things. And you can see that we're actually showing in this log now basically the causal chains here. So the change handler called setUpDates. And then as a result of the post that got done in setUpDates, getDates callback got called. And the interesting thing here, I mean, a little side note, is that this isn't just a call stack, right? Like this is basically a call stack, but the getDates callback, that actually got called back asynchronously. So if you were to look at this in DevTools, you wouldn't see it in the same call stack as all that other stuff. But we're actually kind of tracking that stuff and showing you how these asynchronous things are related to each other. So I can look at this, and I can look at the return values from getDates callback, and you can see that the data I got back from the server is empty, right? So clearly there's a bug on the server. So I'm going to switch to the node code. So this is the JavaScript that's actually running on the node server. And because we were running that in this Theseus thing too, you can see that it's actually showing the same instrumentation information for the server side. And again, I can click on these things to see what happens. So I can click on these calls here. And I can take a look and see, oh, OK, well, it looks like this handle API request got called, and that called getDates. But in getDates, this activity was undefined. And so if I look at the call to that, it looks like I just made like a stupid typo, right? So this is obviously a very simple example, and this is kind of early work. But the idea is to make it so that by sort of watching what your application is doing, we can give you rich information that you can use for debugging after the fact, as opposed to you having to sort of proactively figure out all the places where you have to essentially manually instrument your code yourself with log statements and breakpoints and all that kind of stuff. So this is actually, let's turn this off. So they've started putting this stuff up on GitHub already, so it's open source. So if you have brackets, you can check out Adobe Research/Theseus, and you can just install this as an extension into brackets to check it out. And definitely give them feedback on, is this useful? What other kinds of information do you think could be collected? What are different ways you might want to query that information? OK, so that was Theseus. The second thing we're going to show is this idea called Insta Bug, and this was actually done by Peter Flynn, who you might have seen his talk. Did anybody see his talk on Wednesday on performance? It's a good talk. You should check it out on the recording if you didn't see it. But anyway, he's going to talk about something totally different now, which is called Insta Bug.
Almost. There you go. Can everyone hear me all right? Cool. All right, so how many people have seen this demo from Brett Victor from a while back? You have basically a code editor on the left. On the right-hand side, you have this visualization of how the values of variables change over time. And as you edit the code on the left, the visualization on the right-hand side is actually updating continuously as you're typing, so you're getting this sort of live feedback. How many people have seen that demo before? All right, cool. This is the kind of sort of novel thinking that gets me really excited about the future of JavaScript tooling. And so I've actually been working on something along these lines, and I'll basically to looking at some of the ways that you can branch out from this idea. So let me show you a bit of that. Just going to take a little quick switcheroo here. You already turned off Theseus? Okay. So I don't know if I can make the font much bigger than that. I have it still fit, but hopefully it'll be OK. So for those of you who haven't seen the demo, here's basically how it works. You have some code, and as you make edits in the code, you actually see the stuff on the right-hand side here is updating in real time. It's showing me how each value changes as it's assigned, as it's modified. So as I'm making edits here, you can actually see those values being modified. So what's really cool about this is it's taking this traditional three-step cycle that we're used to. First, you write code, then you test code, then you debug the code to find problems, to fix the problems. It's taking those 3 steps and it's fusing them to this one continuous ongoing process. So while you're writing code, you're continuously seeing live feedback as to the results of executing that code. And when the result isn't what you expected, you already have this rich debug information on the screen right there. And I think that's actually a combination of sort of 2 interrelated ideas. The first is this sort of idea of continuously re-executing the code as you're making changes, and to be able to show you that live feedback. And then the second is this really rich visualization you see on the right-hand side that's broader on the time spectrum than when you get from a traditional debugger. So a traditional debugger, right, you're looking through this really narrow window. It's just an instant in time, and that's all you can see. And you can step forwards, but you're only looking through a little sliver. And this is showing you a more holistic view of the whole history of the execution of the flow of execution through the code. And I think that right-hand side, that visualization, can actually be made semantically more rich in other ways, too. Let me show you a couple ideas that we had around that. So one thing you could do, for example, is you can gray out blocks of code that aren't being executed so that your eye is just naturally drawn toward the actual code path that the execution took. Then if you have something that, let's say, a loop being executed, we can show you the number of iterations that it executed. Just a really quick way to get it, wrap your head around what the code's been doing. And then let's say if you have a variable that's being used as an index into an array, we can actually show you the value of that variable, not just as an integer sort of floating out of context, but actually as an indicator on the array itself, showing you what member of the array that value is actually pointing to. So it's basically beginning to give you sort of this richer semantic view of what the values in the code mean and what the execution of the code looks like over time. But skipping back to that first thought, the sort of continuous re-execution of the code, one question about that is whether that's actually sort of a fatal flaw in this whole idea. Every time you see demos like this, it's always either a toy snippet of code, like this one, or it's some kind of run loop, like in an animation or a game, that sort of lends itself naturally to being rerun over and over again, because that's what it's designed for. And so continuous re-execution makes a lot of sense there. But you can't continuously re-execute an entire web app as you're typing, right? Like, what does that even mean? It doesn't make much sense. This whole idea is really predicated on taking a set of code and isolating it along with its inputs and sort of mocking away the rest of the world to be able to do this continuous re-execution. To me, that sounds a lot like the process of writing good unit tests, isolating code, mocking things, et cetera. So I think it's really interesting to look at all this from the perspective of unit testing and TDD. And I'll show you an example of what I mean by that. So here's a, oh no, we got the line wrap issue. Let me make the font a little smaller again. Sorry, the low resolution is a bit of an issue here, but no, it's lower resolution than I thought. Okay. Huh. Yeah, it keeps, there we go. The font's going to be really small. I don't know why we're getting that problem. I think it's on the other branch maybe. But anyway, so, no, that's okay. Hopefully, I'll kind of talk through the code, so if it's hard to read, hopefully it'll still make sense. This code right here is it's a function that takes an argument. It's a really crappy implementation of converting a number to a string. And so I can fill in a hypothetical argument value here to begin to see what the code is doing. But I can also fill in an expected value. And you can see that the code's doing the wrong thing. It's actually getting stuck in an infinite loop. But let's set that aside for a second and sort of do tests first. So I can add a few more test cases here. 0 is a good edge case. Negative number is another good edge case. And like I said, this code's really crappy. It's failing every test case I can possibly think of. But that's fine. Let's go back to the first one we tried, the 120, and see if we can actually get a sense of what's going on here. So we're expecting num to converge down to 0. And instead, we can see really easily here that it's actually just getting into smaller and smaller floating point numbers. So that's one of these sort of traditional pitfalls in JavaScript that interior division doesn't truncate. And we can really easily fix that with just adding in a math.floor here. Oh, no, it's doing it again. Let me take some white space out of the code. Sorry. There we go. So now we can see that we're running 3 iterations for a 3-digit number. That's what we expect. The single-digit case is actually passing already now, but if you can see this, it's actually outputting 0, 2, 1 instead of 1, 2, 0. So it's concatenating the numbers in the wrong order. We're still getting bad output. That's luckily really easy to fix too. So there we go. Now we got the 2 cases passing. Fixing the 0 is really easy. I can just add in a little extra thing here. And you get the idea. And I can make these fixes sort of feeling confident that I'm not breaking other stuff because all of these test cases are being re-executed continuously. So if I did something stupid here, like making it always return 0, you'd immediately see the feedback that some of the other test cases had basically gone red. And one thing this brings to mind is I think it's really important to sort of begin seriously thinking about blurring the line between these sort of one-off test values that we throw around when we're initially writing code and getting it up and running versus the more formal unit tests that we keep around in the long run. And one way that we can do that is to actually keep track of the history of test values that you've been using, like we do here, and then actually generate an initial set of unit tests for you, sort of scaffolding based on the testing that you've already been doing. So, yeah. So these are just a few ideas. I think there's lots more really awesome ideas in this space, and I'm really looking forward to the day that we can start using tools like this on real-world, large-scale code bases. So thanks, and back to NJ.
Totally on the wrong branch for that. Sorry about that. Yeah. All right, let's see if I can get this thing back on the right way. OK, is that good? OK, cool. So I want to talk a little more about this idea of sort of live JavaScript. So this is actually live JavaScript editing and sort of being able to see results as you edit. So how many people saw Peter van der Zee's talk a few hours ago? Oh, good, a bunch of people. Did you see? You saw your own talk, awesome. So he did this great job showing an approach to this. There's been a lot of activity in this space. I don't know if you've heard of Lighttable, but those guys are looking into this. I think some of the other sort of web IDs have been looking into this as well, and it's something that obviously we've been thinking about too. And I worked on this part, and I didn't think you needed to see my face behind me on the screen, so I didn't bother to put a picture of myself in here. But so I've been thinking about this and sort of looking into an approach to doing this that is sort of interesting, but also a little bit weird. And so this is definitely going to be maybe a little bit more grotesque than you might want to see, but hopefully you won't claw your eyes out. All right, so let me give a little example of what we have in brackets today, and then I'll show how we can do things differently. So right now in brackets, actually I'll switch to a different project here. We have a notion of live development, right? So the idea is you can go into an application here or a website, and I can open it in the browser in this live development mode. And then for CSS, we can do things like, as you make edits, I can bump up the font size here, right? Like as I'm editing the color, you can see that it updates the color in the browser as I'm typing. I can do things like edit padding and whatever, right? So this is sort of it kind of really makes this really immediate feedback loop between what you're doing, kind of like what Peter was showing. And it turns out this is actually pretty easy to do for CSS because it's declarative, right? And in fact, what we're doing is we're connecting remotely to the Chrome developer tools over a WebSocket, and then we're just pushing new CSS at it, and it knows how to replace that stuff on the fly. Now, the thing is, if you think about doing that for JavaScript, it's actually a lot harder. And again, if you saw Peter van der Zee's talk, he talked about some of the challenges there. It turns out that Chrome does some of that stuff already. So if you push a whole new script at Chrome, it'll actually replace function definitions, at least in some cases. But it won't always work, and I'll talk about some of those edge cases as I do this next demo. So let me actually switch to a different build of brackets that has some different live development stuff in it. This is my prototype code here. And here it is. OK. So this is a really stupid app. Basically, you click this button, and every time you click the button, it shows a new number, or it increments a number, and it prints out a message, right? So in this version of the live development mode, what I've done is I've basically taken the existing JavaScript file, and I've instrumented it in such a way that we can do various kinds of live code replacement on it. So again, somewhat similar to some of the stuff Peter had there. So for example, I can go here, and I can change this to new message. And then without reloading the application or whatever, just pushing a new function definition, you can see that it's showing the new message here. Right? So I haven't reloaded the app, I haven't saved it or anything like that. So that's one thing you can do. Another thing you can do is you can actually add new functions here. So let me go ahead and change this. So let's say I want to do a little refactoring, and I want to make it so that I can add 5 every time instead of a count. And I'm going to do that by defining a new function. So that function is going to take an amount, and it's just going to add that to the count, right? Okay, so now I click on this button. Now you can see that it's now incrementing by 5, right? And again, I didn't reload the app. I didn't save or anything like that. So one thing that's interesting about this case that makes it kind of hard is that this new function I defined and the old function that it's referring to and the code that it's referring to before, like that stuff was all in this module closure, right? So there's this closure out here called mylogger. And that's what we actually use. We put our functions in that to sort of hide the implementation details, and then we call it from this click handler. So I didn't actually re-execute this module, right? Because I didn't want to lose the existing module's state. I didn't want to reset this count variable, right? We want to keep that state. We just want to add a new function into the closure, and we want that function to be able to see the current state of what was in that outer closure. But if you don't re-execute the outer function, then how do you stuff something new into it, right? Because this is JavaScript, and these closures, I mean, that's why they're called closures, right? They're supposed to be sealed. You're not supposed to be able to poke new stuff into an existing closure, and furthermore, have the existing stuff in that closure be able to see new stuff that you add to it if that old stuff gets re-executed without re-executing the whole module to begin with, right? So how does that work? Sorry, was that too much of a rhetorical question there? Okay, all right. How does it work? All right. So let me go through this a little, oops, sorry. All right, so let's talk about the first function replacement case. And I'm not going to go into a lot of detail of this because it's actually quite similar to the technique I think that, that Peter used in his talk. So the basic idea is, let's say I start with this code, right? This is my script that I type into my editor, right? And it says my func, console.log old message. So like I mentioned before, what we do is before sending the script to the browser, we actually rewrite it by basically putting in a chunk of extra code into every function that's in the original script file. And that code looks like this. So you start with the original code, which is here, right? And then I basically say, OK, I'm going to create this table of function replacements. And so every time I enter this function, instead of just executing the code I had originally written, I'm going to look into that table and see if there's a new definition. And if there is, I'm just going to eval it. Otherwise, I'm going to use the original function definition. And then once I have that, I can just call func.apply this comma arguments in order to make it evaluate the same way the original function would have, right? So it's a pretty straightforward trick. And as, again, Peter pointed out in his talk, one of the nice things about it is that if you do this eval in the context of this function, you get all the outer closure state, right? All that stuff stays preserved, right? And then when you want to send a new function over from the editor, right, so the user makes an edit in the editor, you just send it over to the browser, and then it stuffs that back into this table here. OK. So the question, though, is how do we do this other case, right? How do we do this case where you've got a closure that you don't want to reevaluate? You don't want to rerun this closure. And you have some stuff in it that gets basically defined when you first execute it, right? So I define a variable. I define a function that logs that variable. And then I, as the user, I'm in my code editor, and I go and I make some edits. And what I do is I basically introduce this new function that refers to a variable that was already in the closure. And then also the existing function here, I call that new function, right? So there's two things going on here, right? Both the new function has to be able to see the stuff that was in the closure to begin with, this closure instance that already exists. And the old function has to be able to call the new function after its content gets replaced using the technique we showed a little while ago, right? Or in the previous slide. This wasn't that long ago. All right, so how do we do it? Well, we use this grotesque hack, which is with. And so most of you probably know what with is, and you know mostly that you're not supposed to use it. But basically, what it does, right, if you're not familiar, is it was originally intended as this convenience feature in JavaScript, where you basically say, I have an object with a bunch of properties on it. And like every time I refer to one of those properties, I don't want to have to say like someobj.name and someobj.age or whatever. If you wrap stuff in a with block that refers to that object, then what it does is basically takes all the properties of that object and puts it into the local scope. So now I can just say name and age instead of saying someobj.name, someobj.age. So like I said, it's this weird convenience feature. Nobody really uses it. It's actually deprecated in new versions of JavaScript. And it's partly because it's just weird, right? It's injecting all this random stuff into your local scope, leads to ambiguities and things like that. But this is actually the feature that makes it so that we can actually use it to prototype this kind of injection of stuff into an existing closure. So how does that work? Well, again, we'll start with the original code, right, which was there was this module, and it had this variable and this function in it. And so we're going to add a little more code to it. What we're going to do is we're going to start by just creating an empty object, and we're going to store it off in a table so we can refer to it later. And then we're going to say, with that empty object, do the stuff define the things that we were originally going to define in the module. And then take all of the things that were defined in that module and stuff them into this scope variable, right, into the scope object. So because of the with here, all those things essentially get re-added into the local scope here, but that's kind of a no-op, right? That doesn't do anything because they were already in the local scope, so who cares? But the trick is now when you want to go define a new function and you want it to see all that stuff and be seen by all that stuff, you can just wrap it with the same scope object. And then you can copy a pointer to that new function, again, into the scope object, right? And so now, when the new function executes, it sees all of the local stuff that had previously been defined in the module because it got copied over into the scope variable, right? And then if you re-enter this internal function, right, this myfunc, right, which is the same thing that, like that logger function in the original example, right, then it can actually see the new function because it got added to this same scope. So basically what with gives you is a way of exposing and consuming the lexical scope, some random place in your code, exposing it as a dynamic object, a dynamic scope that you can then poke at and mess with, right? All right, so big deal. Like why would you even want to do this, right? Like it's weird and confusing. And so I think the reason that I'm interested in it is because if you went to Peter's talk, he pointed out that there's a lot of cases where it just gets hard to do live JavaScript development well, right? Like it's one thing to replace the content of an existing function that's just going to get executed again, like Peter was saying, or if you're in like an animate loop or something where you're just continuously re-executing it. But if you just add a bit of imperative code somewhere in a scope where you don't want to re-execute that whole thing again, it's not that easy to do. And so there's just a bunch of these edge cases and things that I think are difficult. So what we really want to do is sort of prototype this stuff as much as we can using pure JavaScript and using whatever hacks we need to. But ultimately, I think what we really want to do is lobby the VM makers, V8 and JavaScript Core and SpiderMonkey and all them, to basically add more support for this kind of live development into the VM. The same way that the Java VMs added stuff like hot code replacement and things like that. And again, some of them are already starting to do this. Like there's a little bit of this in V8 already. But if we can get them, if we can figure out like what are the right primitives that we need in the VMs to support this style of live development, then we could get that stuff into the VMs, and then all of the tooling, whether it's brackets or light table or whatever, could take advantage of it. So that's the idea there. OK, that was pretty nerdy. But hey, it's JSConf, right? So let me skip to one more thing, which is, well, it's a different kind of nerdy anyway. And I know I'm running low on time, so I'll try to get through this quick. So this last demo is called Response, and this is not actually about JavaScript development. This is about CSS development. It was done by this guy, Lee Brimelow, who works at Adobe. And so what I'm going to do real quick is, again, for context, I'm going to show you some features that are already in brackets, and then show you how he's building on top of that to provide an experience for responsive design. So if I go back to my example file here, one of the things that we have, one of these features that we have in brackets is this idea of inline editing. So the idea is that if I am in like an HTML tag, for example, and I want to see the CSS associated with that tag, instead of having to like go and dig around in my CSS file for it, I can just hit this quick edit key, and what it does is it actually brings open the associated CSS rule right in line there. So I can just tweak it and then get out. So I can really get into this sort of mode of I'm just like in my same file, I'm just editing stuff from the CSS, and then I can pop out. And we use this idea of inline editing all over the place. Like we use it for for things like colors. So like if I have a color here, I can pop up an inline editor for the color. If you're on a CSS property, you can get docs from the web platform docs project and see it inline and stuff like that. So it's just this sort of UI idea that we had for making it just kind of quicker to work back and forth between different contexts. So what Lee did was he took this idea and he added to it to enable some responsive design stuff. And let's talk about what that means. So I'm going to open his responsive design extension here. That error is totally fine, and it's not a bug in my demo. And so the idea here, and the concept behind this is, so when you're doing responsive design stuff, we're starting to work on things like tools for designers to make it easier for them to do this stuff. We've got this project called Reflow that we've started up for that. But if you're a coder, right, primarily what you're doing is you're living in your code all day, but you might want a little help with sort of visualizing what the results of your responsive design stuff is going to be. So we built this extension called Response, and it's built as an extension to brackets, so it's all built again in HTML and CSS and JavaScript. And basically what it does is it gives you this preview of your website here, so it kind of splits open the brackets window and puts a bunch of stuff in here. And what it lets you do essentially is visually define media query breakpoints and then give you a really easy way to modify them in code. So like here, for example, when I get to about this size, maybe, I want to actually start having the text be fluid. So I can create a media query breakpoint. And then I can use this inspect mode to select an item in the HTML. And let's see if this, oh, it's not going to work because the font size is big. OK, but you can see that it's selected this associated container div in my HTML here. And we can use that same quick edit gesture to see the associated CSS styles. But we're in a different mode now where this is associated with the current media query. So if I now make a change here to the width, it only applies to that media query. So if I make this back bigger again, if I make this bigger again, you can see it's fixed width again out here, and then inside it, it's 90%, right? So it's basically letting me make overrides in an individual media query. I could do the same thing here for this, this grid. I want this stuff to not be so spread out in smaller widths. And so I can go here, and I can make that a fluid width, right? And so now that works as I resize the browser window. And then I could go ahead and make another media query here for this stuff is starting to overflow. So maybe I want to create a new media query breakpoint and then edit that to do display none. Okay. So again, this isn't necessarily what you do. It's not mobile first and it's not best practice and whatever, but it gives you the idea of what the response plugin is doing. And what it's been doing all along is as I've been making these edits to what looks like my original CSS styles, it actually wasn't editing the original CSS. What it was doing was putting those overrides into media query breakpoints that were per these different breakpoints that I created visually. So this is the kind of thing where we don't want to build tooling that takes over your code and spits out a bunch of stuff that you don't understand. It's really about kind of giving you a sort of small amount of tooling that can aid your existing coding workflow without sort of taking it over. And that's the idea with this. All right, so I think I have maybe 3 more minutes, so let me just go. I'll wrap up quickly. So that was 4 different demos of some pretty different things. We've got some JavaScript development, some CSS development. And again, the idea here is to see if any of these ideas resonate with you guys, if there are things you'd like to see, or if you have other ideas, that would be cool. I will make a plug for brackets as a base for this stuff. When we started building brackets as a code editor and we decided to build it in HTML and JavaScript, it was kind of a lark. It was sort of like, hey, let's see if we can do this, right? And we also had this thought that it's great for a tool to be implemented in the same language that its users use, right? So that if you're a person who uses it, you can also hack on it, and you can build extensions to it and all that kind of stuff. But then there was this more subtle point we realized kind of later on as we started finding people building more and more interesting extensions on top of it that we hadn't even ever thought of before, like that response extension, right? It sort of came out of the blue one of these days. And it's really that, by analogy, I don't know how many of you have used Eclipse. Has anybody used Eclipse, right? So it's this Java IDE, and it's built for Java developers. It has some of that same flavor. And they spent a bunch of time thinking about extensibility, right? So, it's a very extensible tool. But at the end of the day, they were fundamentally hobbled by the fact that it was a non-declarative UI stack, right? They had to think of an API that would explicitly let you do certain things. So if you wanted to add an icon to a toolbar, you wanted to add a new panel, right? They had to think up an API for that. But in the web stack, you don't have to do that. It's like that guy, the guy who wrote that response thing, like he just hacked a bunch of stuff into the DOM, and it just worked, right? We didn't have to give him permission. We didn't have to figure out what the right API was going to be before he did it. Now, that's not saying that you never need clean APIs and you never have to think about extensibility. We've thought about it a lot too. But our philosophy is really, put the paths where people want to walk, as opposed to, like, let's try to figure out every possible thing somebody might want to do in advance. And so we found that, at least we think, that makes Brackets a really good sandbox for this kind of experimentation with developer tooling. So if you have ideas for developer tooling that you want to try out, in the context of a code editor, we'd like to invite you to play in the sandbox too. So we're github.com/adobe/brackets. That's the main GitHub repo. If you just want to download to be able to try it out, you can get that at download.brackets.io. And these slides are online at this URL here. And I am NJ and not WebSafe, and that's my talk. Thank you. Oh, and I forgot to say, if anybody wants to come up, I have some 3D printed Brackets logos for you, for people who want them. I think we're kind of running over, so I don't know if we should take questions or. Oh, there's a break. OK, are there any questions while I'm up here? Yeah. The live development right now? Yeah, that only works with Chrome because we're talking to the Chrome debugging tools currently. But obviously, Mozilla is starting to have, they have the remote debugging protocol and things like that, so we're planning to hook that up as well. Uh-huh. Yep. Yeah, we haven't started working on it officially. We've got some prototypes. The main thing is where do you want your code to be stored, right? It has to be in some backend. So we've got like a prototype of it running against Dropbox as a backend, just sort of as a proof of concept. The intention is eventually we'll basically abstract it so you could have any one of a number of backends. But we haven't done the work to actually make that official yet. So we're hoping to do that. I don't know. Can we say? Sort of we're hoping by the end of the year. Uh-huh. So the question was, could we support source maps for these things where we're doing all this crazy instrumentation of JavaScript? And we certainly could. Like I said, this is just kind of a hacked prototype. It's not sort of cleanly packaged up the same way that Peter's stuff was. So, but yeah, that's definitely what you would want to do if you were going to go with this instrumentation-based approach, for sure. Any other questions? Oh, yeah? Mm-hmm. Yeah, no, we would definitely have to do that. So for which part were you talking about? Were you talking about like the live JavaScript replacement stuff, or were you talking about some of the other stuff? Yeah, that's the other thing is that basically when you deal with real world JavaScript, you have all of these things you have to worry about, right? You have to worry about people putting stuff in modules and asynchronous loading and stuff like that. So like I said, that's part of the hard problems that we have to think through. And this is just like the first tiny slice of what we would have to think through to get this to work in kind of a real world production environment where you actually want it to work. Anything else? All right, thanks a lot.